We will discuss about the reactions of alkenes and their production methods. Before moving to production methods and reactions of alkenes, we will know about the organic regions involving in those reactions. So organic regions are basically of three types based on their charge. They are electrophiles, nucleophiles, and free radicals. Electrophiles are the electron deficiency species or positively charged species. So we know that. So for example, we will take hydrogen. Okay. So if we consider a hydrogen plus atom, so here's a nucleus, no electrons are there for hydrogen. Hydrogen plus ion, no electrons are there for it. But it has one s orbital which can have two electrons. So hydrogen plus ion likes electrons. Electro means electrons, philes means likes. So H plus ion does not contain any electron, but it has empty s orbital. So it can have two electrons. It likes two electrons, so it is known as electrophile. Positively charged species or electron deficient species are then known as electrophiles. Here NO2 plus ion is there, Cl plus ion is there, and H plus ion is there as examples. We will discuss about the nucleophiles. Nucleophiles are the electron-rich species or negatively charged species, or the neutral molecules containing lone pairs of electrons also can be considered. So here, if we take Cl minus to an example, it has filled its orbital and it has more electrons. It is rich in electrons. So such species which are rich in electrons are known as nucleophiles. That means negatively charged species are rich in electrons. Negative charge mean electrons. No? So the species with negative charge or the species which are rich in electrons are known as nucleophiles. Except that the molecules containing lone pairs of electrons, here you can see nitrogen has two electrons, that means one lone pair. In H2O molecule, oxygen has one lone electron pair. So we consider molecules with lone pair of electrons to be a nucleophile. And here ammonia, water, chloride and cyanide ions are considered as nucleophiles. Then free radicals. I have discussed in detail about free radicals in a previous video, and here free radicals are resulted by homolytic breaking of covalent bonds forms free radicals, right? Free radicals are formed by homolytic breaking of covalent bonds. For example, think here chlorine is bonded by a covalent bond. So this bond has two electrons. One of this electron is taken by this chlorine and one of this electron is taken by this chlorine. So in such cases, we call the formed products. The formed products are like this. We call these formed products as free radicals. They do not bear charges. So here, in indicating homolytic bond breakings, we do not use an arrow like this. We use just a fish hook like this, right? So, free radicals do not bear any charge. They are neutral species, each having one electron. So, we indicate free radicals like this. There are four basic types of organic reactions as addition reactions, elimination reactions, substitution reactions, and rearrangement reactions. Let's see what addition reactions are. Addition of atoms or groups through an unsaturated bond is known as addition reaction. For example, if we consider a molecule like this, right? We can add organic compound to this. I am going to add Br2 for this unsaturated bond. Replacing this unsaturated bond, bromine to bromine can be joined like this. So this double bond becomes a single bond. This type of reactions are known as addition reactions. Replacing an unsaturated bond, addition of atoms or groups happens. So here unsaturated bonds mean double bond or triple bonds. So there are two types of addition reactions, electrophilic additions and nucleophilic additions. We indicate electrophilic additions like this and nucleophilic additions like this. Substitution reactions. Replacement of an atom or groups of atoms by another group or atom. So, they are known as substitution reactions. For example, if we replace hydrogen bonded to this alkane by a chlorine. So I'm going to remove this hydrogen and put chlorine here instead of this. This kind of reactions are known as substitution reactions. We are going to put another atom instead of another atom, right? So such kind of reactions are known as substitution reactions, and there are two types of substitution reactions as electrophilic substitution and nucleophilic substitution. So now we are going to begin the reactions of alkenes. First reaction of alkenes here is hydrohalogenation of alkenes. When a alkene react with hydrogen halide, it produces alkyl halide, right? So here hydrogen halides are HCl, HBr and HI. So we will take an example like this. Carbon, the double bonded carbon, hydrogen, hydrogen, hydrogen and hydrogen. So I am going to add HBr molecule for this. So when I add HBr for this, what happens is this double bond removes and this becomes a single bond. Then two bonds, carbon can have four bonds, two bonds are formed, one with hydrogen, one with bromine, right? Double bond becomes a single bond. Carbon can have four bonds. So now already three bonds are there. One bond with hydrogen, one bond with bromine. We are going to discuss about the mechanisms of these additions from another video. Here my purpose is to introduce you the reactions and production methods of alkenes so we can easily move for organic conversions. We will in detail discuss about mechanisms of these later from another video. Adding HBr or any other hydrogen halide, we cannot add as we feel. Right? There is a rule for addition of any hydrogen containing compound to a alkene or alkyne. That is Markovnikov's rule. We will discuss about this Markovnikov's rule in detail in another video. According to Markovnikov's rule, the adjacent carbon containing more hydrogen gets the hydrogen, while the carbon containing low hydrogen gets the halogen atom. So here this one is a symmetric carbon, right? So when we take these two carbons, both of them have two hydrogen. So in such cases, no issue in adding HOBr to any carbon atom. In such cases, there is no issue. But in situations like this, we can add hydrogen and bromine in two ways. Yes, you can see. Either way you can think. Here in this case, this carbon has two hydrogen and this carbon has only one hydrogen directly attached to it. So if I expanded this, here carbon and three hydrogen attached to that carbon. Okay, do not misunderstand that it has four hydrogen like that. This carbon has one hydrogen and one carbon attached to it. For this carbon, three hydrogen have attached. So we can take these either ways. We can add hydrogen to here and bromine to here, or else hydrogen to here and bromine to here. So in organic conversions, we cannot have such two products. We have to have a single product. So Markovnikov has defined a rule like this. We have to add hydrogen to the carbon, to the adjacent carbon with more hydrogen, and we have to add bromine to the adjacent carbon with less number of hydrogen. So if we think about these two, here this carbon has two hydrogen and this carbon has only one hydrogen. So we have to add bromine to this carbon and we have to add hydrogen to this carbon according to Markovnikov's rule. That product is mentioned here. So we call this as a major product and we have to use this major product in organic conversions. So what is the rule? We have to add hydrogen to the adjacent carbon containing more hydrogen. Right? If there is no adjacent carbon, if there is only one adjacent carbon, think a situation like this. Carbon, carbon, carbon. Double bond is here and two hydrogen are there like this. I am going to add HBr for this. So here this hydrogen, two hydrogen, two hydrogen. So I am going to add HBr for this. What happens here? Only one adjacent carbon is there. For this carbon, only one adjacent carbon is there. Right? I have missed here. No hydrogen like this. So only one adjacent carbon is there. We have to add bromine here and hydrogen here. because more hydrogen for this and less number of hydrogen are for this. Here, if you want to add this hydrogen to the carbon atom containing low number of hydrogen, we can do this, right? That is called anti-Markovnikov's rule, right? Think that in organic conversion, you have to add hydrogen to the carbon atom which contain low number of hydrogen. According to Markovnikov's rule, what happens is hydrogen goes to the carbon atom with higher number of hydrogen. But you have to add hydrogen to the carbon containing less number of hydrogen. So in such situations, what you have to do is adding HBr in peroxide mediums. Adding HBr in peroxide mediums. If you add HBr in the peroxide medium, we indicate the peroxide medium like this. If you add HBr in the peroxide medium, bromine goes to the carbon with higher number of hydrogen. Hydrogen goes to the carbon atom with low number of hydrogen, right? So, we indicate such reactions in this way. Here, directly HBr addition gives this product. Hydrogen goes to the place with high number of hydrogen. Bromine goes to the place with low number of hydrogen. But if we add HBr in the peroxide medium, then what happens is this. Hydrogen goes to the place where with low number of hydrogen and bromine goes to the place where with more number of hydrogen. So this is the anti-Markovnikov's rule. Using the anti-Markovnikov's rule, remember that HBr is the only hydrogen halide accepting the anti-Markovnikov's rule. It only undergoes the anti-Markovnikov's rule. Hydrogen iodide, hydrogen chloride, these two doesn't accept the anti-Markovnikov's rule, right? If you want to add a chlorine here, if you want to add chlorine molecule here, HCl molecule, sorry, not chlorine, HCl molecule here, hydrogen goes to the place with higher number of hydrogen and chlorine goes to the place with lower number of hydrogen. Even though we add HCl in the peroxide medium, the result will be the same without no change. Same for hydrogen iodide. If you want to add HI here, if you want to add HI here, this double bond breaks into a single bond. Hydrogen goes to the place where with higher number of hydrogen and iodine joins to here. If you add hydrogen iodide in the peroxide medium, there is no change in the result. The result will be the same. Then addition of H2SO4. Like this, we have to indicate it in this way, addition of H2SO4. If we add an H2SO4 molecule to an alkene, this double bond breaks and forms a single bond here. And one hydrogen molecule and one OH molecule joins to the carbon. As per Markovnikov's rule, carbon which has higher number of hydrogen gets the hydrogen and carbon with lesser number of hydrogen gets the OH group. When you add H2SO4 For alkene or alkyne, what happens is hydrogen and OH adds to the molecule. Hydrogen goes to the carbon with more number of hydrogen and OH goes to the carbon with less number of hydrogen. Addition of halogens. Here chlorine, bromine and iodine are considered as a halogens. If we put chlorine Cl2, these double bonds breaks and form a single bond, and 2 chlorine joins to these 2 carbon atoms. If I add bromine here, Br2, this double bond breaks and forms a single bond. 1 carbon get 1 bromine. Like that, 2 bromine are now in the alkane. So, then we have to discuss about the reactions with cold alkaline KMnO4. If we add cold alkaline KMnO4 for an alkene, we can add 2 OH groups for the alkene. So here double bond breaks and forms a single bond, and 2 OH groups adds to the 2 carbon like this. So you have to remember each and every reagent and their products to do organic conversions. And the last reaction that we should discuss is catalytic addition of hydrogen. That means we are going to add 2 hydrogen atoms to alkene and make it a alkane. In this case, to add 2 hydrogen, we have to add H2 with nickel, palladium or platinum. We have to add hydrogen with nickel, palladium or platinum. Then we can add 2 hydrogen to alkene. What happens there is double bond breaks and forms a single bond between the carbon. Carbon can have 4 bonds, so remaining bond is formed with hydrogen. Then alkene turns to alkane. So here we have to discuss about 3 preparation methods of alkenes: dehydration of alcohols, elimination of alkyl halides, controlled catalytic hydrogenation of alkynes. These are the 3 methods that you have to discuss in the syllabus. Method is dehydration of alcohols. Dehydration means removal of a water molecule. So, for the removal of a water molecule, we have to add a reagent, that is concentrated H2SO4, and we have to give the condition of 160 Celsius to 170 Celsius. Or else we can put Al2O3 and heat the alcohol, right? That means you have to take an alcohol, and for that you have to put concentrated H2SO4 and give 160 to 170 Celsius condition. Or else you can take an alcohol and put Al2O3 into it and heat it. Then a water molecule eliminates, giving alkene for you. So here we have to remove OH along with hydrogen. Then only it becomes a water molecule. No? So here OH can be removed easily. but from this side or this side we should remove the hydrogen. For that, there is a rule called Safety Saves rule. Safety Saves rule. We will discuss about this Safety Saves rule later. Till then, remember, we have to remove hydrogen from the adjacent carbon containing low number of hydrogen. Right? I'm going to repeat. We have to remove hydrogen from the adjacent carbon containing low number of hydrogen. So here two adjacent carbons are there. This carbon has 3 hydrogen and this carbon has 2 hydrogen. So we have to remove this OH with this hydrogen and make the double bond between this carbon and this carbon. So according to Zaity-Save's rule, we have to remove hydrogen from the adjacent carbon which contains lesser number of hydrogen. So for the dehydration of alcohols, the reagents that we can use are concentrated H2SO4 in 160 Celsius to 170 Celsius condition, or else we can put Al2O3 and heat. These are the two reagents that we can use. Our second method is elimination of alkyl halides. Elimination means removal of halogen atom, right? So here we have to remove this halogen atom as a hydrogen halide. So halogen atom can be removed easily. But with which hydrogen we have to remove this halogen atom? According to Zaity-Save's rule, we have to remove the hydrogen from the adjacent carbon containing lower number of hydrogen. So here there are 2 adjacent carbons and this carbon has 2 hydrogen, this carbon has 3 hydrogen. We have to remove this bromine with this hydrogen and make the double bond here. So here is a double bond. So for the elimination of alkyl halides, the reagent that we should use is alcoholic KOH. Alcoholic KOH. Alcoholic KOH is the reagent that we use for the elimination of alkyl halides. Then the last method of production of alkenes is control catalytic hydrogenation of alkynes. We call this reaction as Lindlar's reaction, right? So we discussed about the catalytic addition of hydrogen before. For that we used hydrogen along with PD, PT or nickel, right? If we add hydrogen in this way to the alkyne, alkyne turns to an alkane. But our purpose is to produce alkene. So, we have to inhibit this reaction. These are some catalysts, right? So, we have to reduce this catalytic activity by adding an inhibitor so we can stop the hydrogenation of alkyne in half a ways, right? So like this, we have to add hydrogen with palladium, but we have to add the inhibitor of palladium, that is barium sulfate quinoline. Barium sulfate quinoline. If we add hydrogen, palladium, barium sulfate, quinoline, we can turn this alkyne into alkene like this, right? From these triple bonds, one bond breaks and add two hydrogen to surrounding carbons. So if we add hydrogen and palladium only, this alkyne will directly turn into alkene. Sorry, not alkene, alkane, right? If we only add hydrogen and palladium directly, this alkyne will turn to alkane directly. Here our purpose is to produce an alkene, so we are going to inhibit this reaction by putting barium sulfate quinoline, right? For nickel N, so here in hydrogenation we use hydrogen with palladium, platinum and nickel, right? These three regions, one of these three regions can be used at that time, but the inhibitor barium sulfate quinoline answers only to palladium. So in control catalytic hydrogenation, the only catalyst that we can use is palladium. We cannot use platinum or nickel here. This is the end of our lesson today. I hope to do organic conversions with you from this lesson in the future video. And also I hope to discuss about the Markovnikov's rule and Satyshev's rule also. So subscribe and stay tuned until the next video.